봅시다. 아주 용어야 되잖아. Sorry. Okay, I'm gonna go over 2.4 exact equations. So far, what we are doing is to solve first order linear equation. First order ODE, right? 2.4, especially uh, they are introducing exact equation, which is one of type first order ODE. Okay. Mm, Let me introduce a level curve. Okay. So level curve is in the vector calculus, which is I mean in this one from the function with the multivariable. Okay, so level curve of the function f of x comma y. Okay, and then specifically, I mean this is the set of what? The set of all points x comma y such that s dot theta f of x comma y is equal to c. So here for some constant c. So here c is in a real number. So example is just x squared plus y squared equals 1. Okay. So example is x squared plus y squared is equal to 1. So now we can define here the f of x comma y is this. Okay. So then if you see that the graph of f of x comma y, since this is the function with a multivariable, so in general, the graph of f must be a surface like this in 3D. Okay, there's a z-axis, here x-axis, and the y-axis. Here, this is y-axis, this is x-axis, this is something like this. But the graph of f of x comma y, see that here, see, this is the function value. So this one represents z value in a three-dimensional space. So three-dimensional space is fixed constant c. C is a constant, okay? So which means that the graph of f of x comma y must be on a line which are parallel to xy plane. So for example, in this case, x squared plus y squared is 1 must be the circle, okay, in x three-dimensional space, circle on here. Okay. So this is 1 right here. So 1 is z value. Okay. So as you can see that this is a circle is on the plane is what? No plane on above the xy plane by 1 unit. Okay. So anyway, so this is level curve. So level curve is what the function with a multivariable, but z value is fixed and constant. Okay. Now we take a derivative. Okay. How can you here? So let me introduce the total differential. Okay. So let's see df. Oh, let me see total differential of f. Okay. So denoted by df. Okay. So here f, capital letter f is the function with a multivariable f of x comma y. Okay. So since the f is the level curve, okay, the function of level curve. Okay. So then we find out total differential is df of x comma y This is equal to partial f and a partial x and the dx. And the plus, this is a formula. Partial f partial y and the dy is equal to derivative of c. But c is a constant. So derivative of constant is 0. So this is 0. I know this is derivative of what? Yeah, derivative with respect to no matter, the value, no matter what values, the derivative constant is 0. So right-hand side it turns out to be 0. Okay. So now see, we got this one. I know. This is 0. Okay, this is 0. So finally we got the partial f, not partial x. This is a derivative f with respect to x times dx. Okay, and the plus partial f and the partial y and the dy is equal to 0. Okay, so this kind of, the differential equation with this form is called the exact differential equation. And now, let me say simply, let's say this is m, x comma y. Okay, let's say this is n, x comma y. Okay, now from there, so okay, say now we just rewrite. Okay, rewrite this one with a new expression of partial f partial x partial y with m and n. Then we got this m x comma y and dx plus n x comma y and dy equals 0. Okay, so now here where the partial m partial partial f partial x is equal to m x comma y, and then partial f partial y is equal to n x comma y. Okay, so this is an exact equation, exact differential equation. So that's the definition of exact differential equation. Okay. So what does that mean? We already know the solution. What's the solution of the exact differential equation? Actually, we did derive exact differential equation from what? Total differential of f, which means that f is the solution, right? Isn't it? Where, how we got this? How did we get this? We got this one from this, and then we got this one from this. We got this one by taking total differentiation of f. F is a level curve. F is a level curve, okay? So f of x comma y, let's see, this is f of x comma y, okay? So this is a solution to that exact differential equation. Okay, so whenever differential is given, you gotta find out what? F, capital letter F. Okay, well, how can you find the capital letter F? Okay, so here's a clue. If this is really exact differential equation, then partial and partial x must be m, and partial y equals n. So when you take the integral with respect to x on both sides, so we can get f, right? Or you just take a integral of f with respect to y, then you can get f. Right? Do you follow me? Okay. So the example. Okay, I know. I think I give you example. Example. dy dx is equal to minus 2xy squared and then plus 1 divided by and then 2x squared y. Okay. Is this really? You may just try to use method of separable. Or okay, what we learned so far for solving first order ODE. The first one was what? Separable, right? The second one, for finding on the analytic solution. Okay. The separable, second one, the linear, right? Okay, is it separable? No. Is this linear? No. Okay, then is that exact? Okay, let's figure out if this differential equation is exact. Then we have to rewrite this differential equation as this form. Okay, so first one, I'm gonna multiply dx on both sides. So dy is equal to minus 2xy squared plus 1, and then over 2x squared y times dx, isn't it? Because I just multiply by dx. And then I'm going to multiply by 2x squared y on both sides. Okay? So this is a numerator. That means numerator means in Korea, 분자. Okay? Denominator is 분모. Okay? So here, this is numerator, right? So I'll multiply by numerator on both sides. So then we got 2x squared y and then dy is equal to minus the 2xy squared plus 1 the dx. And then move this guy, the expression on the right-hand side to the left-hand side to make a 0 on the right-hand side. So 2x squared, let me just write down this one first. So 2x squared, 2xy squared, sorry. The plus 1, the dx, and the plus 2x squared y dy equals 0. So now, okay, let's say this is m, x comma y. Keep in mind this, the exact differential equation, the algebraic expression in front of dx must be m, okay, and the algebraic expression, in front of dy must be n. So this is m, this is n. Okay, now what are you going to do? Can you say that this is exact? Not yet. What? What will we do? We have to, prove that, the positive and positive x equals m, positive and positive y is really n. But we do not know f, right? That's weird though. This is we don't know f, and this definitely we don't know f. This is what we want to find out because f is solution. But we do not know f. Then how can you show that these two guys? How can you check these two, conditions? That's not the end. To show that this is a exact differential equation, we have to show that m is really partial f of partial x, and then this n is really partial f partial y. But we do not know f. Yeah, because f is solution. So here's the idea. From here, partial f, partial x is m, right? Which means that when you take a partial f, partial x, when you take a partial derivative with respect y on both sides, then we got partial m, partial y, isn't it? And then the partial f, partial y is equal to n. That's what we want to show that we want to figure out, right? So, but we take a partial derivative with respect x on both sides. So we got this is equal to partial n, partial x. So this is n. Okay, sorry. Okay. So look at the left hand side. This guy, this one, and this one. You see, these two guys are same. Because here we assume that f is a continuous, okay, kind of smooth, differentiable. So in calculus, in a vector calculus, calculus with multivariable, they say that if f is continuous and the differentiable, enough, then the order of a partial derivative will not change the result, which means that partial f, taking the derivative f with respect to x first, and then taking derivative with respect to y must be equal to taking derivative f in reverse, y first and x second. So these two guys must be equal. I know this is a derivative x first, and this is second. But y is first, this is second. But it doesn't matter because f is continuous. So, okay. Now then, which means that partial and partial y must be equal to partial and partial x. So this is equal this is equal that, this is equal this. So what are you gonna do? I'm gonna take m. I'm gonna take derivative of m with respect to y. Partial y. And I'm gonna take derivative of n with respect to x. Okay. So partial and partial y gonna be what? So when you take m, the multivariable function with a multivariable derivative function with a multivariable with one single variable, then we consider the other variable as constant. So 2xy squared, derivative of 2xy squared with respect to y, then we're considering 2x as constant, we can say coefficient, doesn't matter. Then what? We're gonna get 4xy, right? 4xy. And then derivative constant is just 0. That's gone. And this guy, taking derivative of 2x squared y with respect to x, then we consider y as constant. So we got 4xy. You see? These two guys equal. It turns out that these two guys are equal, which means that what? M must be, I don't know what M is, F is, but we can say N is positive f of positive x. N is must be, the derivative of something with respect to y. Okay. We showed that this one. I just showed that this. Okay. So now we can say that yes, this is exact. Third one, is that exact? Exact? Is separable? No. Linear? No. Exact? Yeah. No. No. Yes. Okay. So now we're gonna learn more types, other types than separable linear exact. So when you solve the differential equation, first order differential equation, first thing you have to do is to figure out type of differential equation. Key minus. I'm not going to tell you this is exact. I'm not going to tell you, this differential equation is a separable in test. So when you get a test and then got question solving differential first order ODE, you got to figure out type of differential equation first. Okay. So now what are you going to do? Here's the theorem. Okay. So here's the theorem. Okay, so from that theorem, we're gonna figure out how to find f. We didn't find the solution yet. We just figure out, okay, this is the exact. Okay, so far. So how can I find the solution then? Yeah, see, we're gonna get clue from that theorem. Suppose the okay, first partial derivative m x comma y and n x comma y continuous in a rectangle R. See, let's say R like this. Script R means the domain of the solution. Okay, so f of x comma y. Yeah, so here, yeah, so we definitely want to find out solution f of x comma y in the domain R. What is R? Rectangle. So, in a let me visualize. So x y z. like this. Here's X, and this is Y, and this is Z. Okay. So let's say here's a C. I don't know what C is, because we're talking about limit for f of x comma y c, right? So maybe here's a plane right there, infinite plane, right? And then domain is I don't know, maybe right here, for example. Okay. So this is R, domain R. So we're talking about differential equation, okay? And then the solution to that differential equation's domain is this. Okay, so you don't have to really care about this. Okay, we're gonna focus on how to methodology, how to find our solution. Okay, so just saying you just accept this one as a domain of the solution f. So or then okay then mx comma y and the dx the plus n x comma y then dy is equal 0 is an exact equation if and only if and only if what? Posure m, posure y is equal to posure n, posure x for all point in the domain R. Okay, so that's what I talk about, right? So far, right? But let me prove. Okay, so see, give me a second. This is exact. This is an exact. Okay, this is exact is equal to this. That's the key point. Okay, so how can I prove this? Okay, if and only if means what? Sufficient and necessary condition. So we gotta show that this and this. Okay, which means that if this is exact, then this is true. That's this one, right? The other statement, if this is true, then this is exact. So we prove this way. Okay, so okay, I'm gonna assume that this is exact. Okay, so if the equation is exact. Okay. Exact equation. It's exact. Okay, exact equation is an exact equation. Okay. So then what? Then by definition of the exact equation, what? And what's the definition of exact? So the differential equation has form like this. Okay. And what? Partial f, partial x is equal to m, right? And partial f, partial y is equal to n, right? Okay. Okay. And then give me a second. So you see that the assumption? Suppose that means assumption. Okay, assumption. Assume that first partial derivative continuous. Okay. So first partial derivative continuous means that this because of that we can say that let me write down. Since their partial derivative are continuous by hypothesis partial f partial x and partial y is equal to partial m partial y. And this is equal to partial x and partial f partial y. This is equal to partial n partial x. So I proved it. I proved that one. This is equal to what? This. Okay. So this way, that way, I just proved that. I just proved this way. The second one, I'm going to prove that way. So we assume that the partial m, partial y is equal to partial n and a partial x for all x comma y in the domain, okay, rectangle. So what are you going to do? Now we will construct what? Yeah, we're going to construct the f of x comma y such that partial x is equal to m and partial y is equal to n. Okay, so that's the if we can construct the f such that partial such that this is then what? The differential equation must be exact differential equation, right? Okay, so I'm gonna prove it this way. What are you gonna do? First, we define f of x comma y. Okay, so we're gonna construct. Okay, how can you construct it? Construct the f. Okay, we just define f as what? The derivative integral of m x comma y, integral of m with respect to x, and then plus g of y. How come? You will see. You will see. Okay. So now in this here, keep in mind this. Here, g is a function of y alone. Okay. Okay. Why we where that comes from? It comes from the integral f with respect x on both sides. From there, you see that when you take an integral to find out f, I mean to consider f satisfying this, then the m is given, right? M and n are given in the problem. You see, exact differential equation this. Here, m and n are given. Okay, f is that unknown. So we take integral partial f and partial x dx is equal to integral and now m and dx, right? So when you take an integral f with respect to x, x here, the derivative integral cancels that out. So we got f, the plus constant. But here, constant is what? Because f is a function with a multivariable, and then integral with respect to x, and g can be a function of y alone. This is constant integration, and the right-hand side is this. So from here, we got this. I know when you move this onto the right-hand side, then the sign will be changed to minus, right? But eventually, the sign of g will be determined by initial condition. You don't have to worry about, care about the sign of g eventually. So the f is what? This is integral m and the dx minus g of y, but it changed the minus to positive because sign of this guy will be determined by initial condition. Okay. Okay, let me just keep going. I told you, the sign of g of y will be determined by initial condition. So it doesn't matter, plus minus. So that's why, anyway, I defined f as like this. Now what are you gonna do? We take derivative f with respect to y. Okay. So now we take a derivative, partial derivative f with respect to y. Okay. So, oh, sorry. Before doing that, we take a derivative of x. Sorry. X. So then what? Derivative of this guy with respect x, then integral will be cancelled out with a partial derivative with respect x. So m will be left. And then derivative of g with respect to well, x is going to be 0 because this is a g of y alone. This is a function of y alone. Okay, so I just proved that. I just showed that the f defined by like this satisfying this. Okay, what? The second one, we need to show that what? Partial f of partial y equals n, right? Then we can show that it's complete to show that the what? The differential equation, that differential equation is exact. Okay. So now to show that partial and partial y equals n, we just take a derivative f with respect y. So f, we define f as like this. Then taking derivative f with respect y, the right hand side going to be partial and a partial y, the integral and the m x comma y and the dx, and then plus and then g prime of y, right? Because g prime means a partial derivative with respect to y. So now what are you gonna do? Here we're gonna take derivative x, okay, partial f and a partial y on both sides, okay, partial x and a partial y integral m x comma y and dx, and then plus g prime of y. Okay, so look at the right hand side. Partial x, partial x, and the partial y, and then integral. This is integral with respect to x. Now we can change the partial derivatives. It's possible. Okay, so we got partial y, and a partial x, the integral m x comma y and dx. Okay, and then plus, what's the partial derivative of g prime with respect to x? 0, right? Because this guy is a function of y alone. Taking derivative with respect to x, 0. And then now, what is this? So this is derivative of x, and this is integral with respect to x. Cancel them out. So we got m x comma y. Okay. So now we got this. This is equal to a partial m partial y, right? Okay. Right. And then now what are you gonna do? This is equal to, but you see that? Here, what we assume, partial and partial y is equal to partial and partial x. This is assumption, right? We do it this way. So here, we assume that what? This is true. Okay? So we can use that assumption, okay? So now, this is equal to partial n and a partial x by the assumption. Okay? So now what? We got this one. This one is equal to what? This. Okay. Okay. Now what? Then what? We take out. We take out. So partial f partial y equals n. So the partial f partial y is equal to n. You see that? This is second condition we need to show that the differential equation is exact. See that? So we show that partial and partial x equals m, partial and partial y equals n. Proof is done. Okay, I just showed that. Okay. All right. So keep in mind this. If you want to figure out if differential equation is exact, you gotta show that partial f of partial x equals m, the partial f partial y equals n. Okay. So keep in mind this. This is actually n x comma y. Okay, n x comma y. So let's see example. Yeah, from here, what? Actually, we can find out. We got the method for solving exact equation. Okay, where? This one. We got it. How we got second one and the first one? You know, this is conditions to be that differential equation exact. Because all very first step was to define f as like this. So you want to solve the exact differential equation, you need to take integral of m and then add g of y. And then you got to find the g of y by taking integral f, by taking derivative of f with respect to what? X. Oh, sorry, y. I'm sorry, y. This one. Okay. So here's a methodology. This is in a textbook, by the way. The method for solving exact equation. M dx plus n dy equals 0. The first one. If m dx plus n, yeah, it's kind of step one, okay? Step one. If m dx plus n dy equals 0 is not exact, quit. Okay, what that means? You need to apply other method, okay? Okay. If it is, then yeah, we apply. I mean, put the formula f of x comma y is equal to integral m x comma y and a dx and a plus g of y. Okay, let me say this is star equation number star. That's step two. To find, okay, m is given, right? So it's not a big deal to find the integral of m. How about g of y? There is no clue at all. So to find the g of y, we do something. We have to do something. Then we need to take a derivative of this equation with respect to y. Okay, so to find g of y, okay, we differentiate both sides of this equation star. So partial f partial y is equal to partial y of integral m x comma y the dx and then plus partial uses g prime, g prime. Okay, then step three. I mean, what? You see that? Partial f of partial y is what? This is equal to what? N, right? This is equal to n. Because we already determined, we determined that the equation is exact already in step one. So partial f partial y should be n, okay? And so what? So what? So here then what? This is given. We can find out this. This is unknown. So this is the only unknown this equation, right? This is given. There's a given. So we can find integral. And then we can take we can take a derivative. So that one turns out to be a certain algebraic expressions, and this is also algebraic expressions. So this is only unknown. Okay. So we take integral. Find g of y by integrating g prime y with respect. WRT means with respect to. Okay, that means with. So in Korean, it's kind of higher. I think that's the what it means with respect to y. And then step four. Most of case, I not most. I think all cases for the exact differential equation, solution will be written as implicit form. So the solution to the exact differential equations, y is equal to 0, is given in implicitly by what? F of x comma y is equal to c. You can put any number for this into c for finding general solution. Okay, but when you find a particular solution using the initial condition, you can find out c. Okay. Here's example. Okay, here's example. So 2xy minus secant square x dx plus x squared plus 2y, the dy equals 0. So here's solution. So this is m, this is n. Okay. Good. All right. So m is what here? I mean, so okay. What is step one? Step one is to figure out if this guy is exact. It means that we take take derivative of m with respect to y, right? Then this is going to be negative to y. We got 2x, right? And then what about the derivative n with respect to x? It's going to be 2x. Okay, so this is exact, right? So the equation is exact equation. Okay, now step two. So now f of x comma y is we define f of x comma y as integral of m, right? The dx plus g of x, g of y. Is it? So now what's the derivative integral of m? Guys, hello? What's the integral of this guy? Yeah, x squared y, right? Then what's the interior derivative of secant squared? Okay, minus tangent x. Okay. Then I know plus c, but let me add c into the g of y. Okay. So what here is a g of y. Okay. Now step 3. So we're gonna find out g of y, right? To find out g of y, we take a derivative, both sides with respect to y. Okay. So partial f, partial y. But that is what? Partial f, partial y. This is equal to what? N, right? What is n? N is this. Is it? So this is n of x comma y. But n of x comma y is given in the problem, x squared plus 2y. Okay. So now then okay, this is gonna be what? X squared and then plus g prime of y. So now then, which means that implies then g prime implies then g prime y is equal to 2y, right? Because the x squared right there, here's x squared. Cancel them out. So we got 2y alone. I mean, 2y, only 2y left in the left-hand side. So, okay, so that's all we got 2y. And then, which means that your y is going to be y squared plus c. Okay. Okay, we figured out. I know there's a c, but c will be determined by initial conditions. Okay. So the problem is just find the general solution to the differential equation. Okay, they're not asking for solving initial value problem. So because I don't see initial condition right there. So step 3 and step 4. So yeah, so f of x comma y is gonna be what? This guy right here, you see? We got so far f of x comma y is equal to Oop. This guy is equal to this, right? This. And then GY is this, right? So f of x comma y gonna be x squared y minus tangent x, and then plus y squared plus c is equal to actually to c, right? So let me combine that c and the c on the right hand side is equal to c. Okay, so this is the solution. I mean, implicit form of the solution. Okay, so or we can say x squared y minus tangent x plus y squared minus c plus c equals 0. Doesn't matter. Is it minus c? I told you it doesn't matter. The sign of constant inversion doesn't matter. Okay. Okay. So here's an example. Another example. I'm not gonna solve it. Okay, because we don't have time. Please solve it by yourself. 1 plus e to the x plus e to the x times y, and then plus x times e to the x y dx, and then plus x times e to the x plus 2, and then dy equals 0. Okay, so the answer is it should be x plus, and then x times e to the x y plus 2y plus c equals 0. E to the x, what is e to the power x, but in short we say e to the, okay, like a to the x. What's the a in it's called the base, and what is x? Exponent. Okay, but a exponent e x is something weird. So normally we say a to the power x. In short, a to the x. Okay. All right. So that's for the 2.4 in summary. Okay. And then we move on to the 2.6.